Hi. In this next set of lectures, we're going to look at a series of models that help us try and understand an empirical phenomenon. And that empirical phenomenon is this. It's that if you look out there in the world, you'll see that groups of people who hang out together tend to look alike, think alike, act alike. So what we want to do is we want to try and make sense of why that's the case. First, let me sort of explain what I mean a little bit. So if you look at a city like Detroit, this is a census map of the city of Detroit. What you see is each blue dot represents a city block that's majority African American, where a majority of the people living in that block, census block, are African American. The red dots are blocks that are majority Caucasian. So what you see if you look at the city of Detroit, you see incredible segregation. So this shows that people literally choose to live with people who look a lot like they do. But it's not just this sort of sorting effect. Another reason that people who sort of are hanging out together look and act similarly is that, well, we change our behavior. We moderate our behavior to match that of people around us. So, for example, take smoking. It could be that you don't smoke and you start hanging out with a bunch of people who do, so you may have an occasional cigarette. Or alternatively, you may have spent your whole life smoking, but now you hang out with a group of people who don't smoke, and so you say, you know what, that's it, I'm gonna stop smoking. So it's these two forces, one of them which is sorting, or what sociologists call homophily, that we sort of choose to hang out with people who are like us. And there's this other effect, which is we choose to start acting like and believing like people we're hanging out with. And so both of these things are going to create groups of people who look similar to one another. Okay, so what we want to do is we want to try and get some understanding of how those processes work through some simple models. Now, these may seem like sort of fairly obvious things to look at, but what we're going to find is when we construct models, we get some pretty interesting unexpected results. Okay, so let's get started. What's it going to look like? What are the lectures going to look like, in this unit, in this module? We're going to start out with a famous model constructed by a guy named Thomas Schelling. And this is a model of racial segregation, and it's sometimes called Schelling's tipping model. In that model, we're going to see how it's a little bit more subtle than we might think about what causes those segregation patterns like we see in Detroit. After that, we're going to look at a model by a guy named Mark Grenovetter, who looked at sort of people's willingness to participate in some sort of collective behavior. This could be a riot, this could be a political uprising, it could be a social movement. It's a very, very simple model. After that, we're going to extend this Grenovetter's model to something I call the standing ovation model. This is a model that my friend John Miller and I developed kind of for fun, but it gets at a really serious point. It's a model of peer effects, where you change your behavior to match that of others around you. And what's interesting about it is the standing ovations, gives us a really nice framework within which to think about this question. And again, there we're going to get some sort of surprising results. All right, and then last, after we've sort of done all this, we're going to talk about something called the identification problem. And that is, suppose it's the case that I look at a group of people and they all seem similar. Well, the question is, did they sort? Did they choose to hang out with one another because they're similar? Or was there some sort of peer effect? Were they hanging out? And did they all start to sort of look and talk and act the same? So that's an interesting question to try and figure out. And these models will give us some understanding of how we can tell those two things apart. Okay, so let's get started. Now, before we do that, one quick comment about the type of model we're going to be using here. Now, a lot of times when people think about models, they think about equation-based models. So when I teach this course, let's suppose that when I teach this course to my undergraduates, one of the things that some of them care about, not all, but a lot care about, is their grade. And so I could say to them, well, here's an equation-based model for your grade. It looks something like this. Your score on the final exam is going to be 50 plus 5 times the number of hours you study, right? So if you don't study at all, you put in no hours of study, you'll probably get a 50 on the exam and fail the course. If you put in 10 hours on the exam, then you'll probably, studying for the exam, then you'll probably ace the test, right, and get an A for the course. So this would be a linear model. It sort of explains how the world works with an equation. Now, the models we're going to do in this unit aren't linear models. They're what are called agent-based models. So what's an agent-based model? An agent-based model works as follows. You have a bunch of agents. These could be people, these could be firms, they could be countries, they could be organizations, but they're the agents, the objects of the model. Now, these agents have behaviors. They have things that they do, rules they follow. Now, in some cases, these rules might be optimal rules. They might be optimizing. In that case, it becomes what we call a game theory model, a rational choice model, where individuals are doing the optimal thing in the context of the model. In the models we study here, they're not going to be optimizing. They're going to be following just pretty simple rules. And then the third part of an agent-based model is, once you've got all these agents following all these rules, that creates something at the macro level. It creates some sort of outcome. And so what we can do is then ask sort of, what kind of outcome do we get? What we'll find in these models is the outcomes are sort of surprising, and that's, again, why models are so useful, because we may logically think that if we assume agents that follow this behavior, we're going to get outcome A, but when we work through the model and actually, work through all the logic, we'll find, in fact, that maybe the opposite's true, or something, sort of surprising is true. Okay, so that's it. That's the plan. We're going to look at some models of sorting, and we're going to look at some models of peer effects, and we'll learn how the two differ and how the two are also a little bit the same. All right, thank you.